Hello, everyone, and welcome to Polymathy Guide. My name's Kelly, and this video is going to be the fourth video in our Excel Mastery series. And this video is going to cover, and just a little bit of a trigger warning, math. This video is going to cover math in Excel. And some of the things we're going to cover are order of operations. If you haven't brushed up on math in the past 20 or 30 years, order of operations is the order in which math is executed within a formula. And we'll get into that in detail. So first thing you want to do is open a blank workbook so that you can follow along. And in any one of these cells, we can type 5 plus 3. And if we press enter, what we're going to see is that 5 plus 3 remains. And the reason for that is because there are instances in which we want to write words, or we want to write numbers or formulas, and we don't want Excel to execute on that particular formula. We just want it to present whatever it is that we wrote. For example, 5 plus 3. Now, if we wanted Excel to execute a formula, we need to tell Excel that this is a formula. And the way that we do that is we precede any formula with the equal sign. And so here we'll press equals 5 plus 3. And when we press enter, Excel will execute that formula, and you can see 5 plus 3 equals 8. And if we were to select that cell where we wrote the formula, we can see that the formula remains. It's visible up here in our formula bar, and it's also visible in our cell. And if we wanted to edit that, we could edit it either here in the formula bar, or we could edit it right here in the cell. So we'll press enter, 5 plus 3 equals 8, and we'll just do a couple more demonstrations just to exercise all of the basic math formulas. We could say 10 times 5, and again, don't forget, let's precede that with an equals, 10 times 5, and you'll see that there's not the traditional way that we may remember a multiplication symbol as an X. The multiplication symbol in Excel utilizes the asterisk or asterisk. Yeah, asterisk. I'm not sure if it's singular or plural. Oh, well, not important. 10 times 5 equals 50. And so if we wanted to do division, let's say equals 10 divided by, and similar to multiplication, you won't see that traditional division symbol with the dots on either side of the horizontal line. In Excel, division is the forward slash. So 10 divided by 5, we press enter, equals 2, and we'll do subtraction just to round it out. 15, preceded by equals, 15 minus 8, and press enter, equals 7. So also, reminder, all those formulas remain as we go through them. You can see up in the formula bar, they're all still there, and we can edit them as desired. But that's the absolute basics of how you perform a mathematical function in Excel. So let's take this one step further, and I'll get rid of all of these numbers on my scratch paper here. Let's advance this just a little bit. So we'll say equals, and we'll do 2 plus 3 times 4. Now, if we work this left to right, we would see 2 plus 3 equals 5 times 4 equals 20. But when we press enter, we see that's not the answer that we get. The answer we get instead is 14, and 14 is the correct answer. And it's the correct answer because of the order of operations. So when Excel sees that you've indicated a formula by starting um, your formula with the equals symbol, it's going to first look for parentheses. So it looks for parentheses here. It doesn't see any. And so then it looks for exponents. It also doesn't see any. It then goes to multiplication and division, and this is working left to right. And as it works across, it sees I have multiplication in a portion of my formula. So it's going to execute on that portion of the formula. 3 times 4 equals 12. And then it's going to look for more multiplication or division. It sees nothing else. It then looks for addition or subtraction, again, working left to right. And it sees I have addition here. So it will do 2 plus and the previously calculated 12. 2 plus 12 equals, and if I press enter, 14. 2 plus 12 equals 14. Now, if the answer I was going for was 20, we can go back into our formula, and all we need to do is we need to move this addition. We need to make that portion of the formula arrive earlier in our order of operations. And so how we do that is we need to group it in a set of parentheses. So I'll open the parentheses in front of the 2, and I'll come behind the 3 here and close the parentheses. Now you'll see when I did that, Excel helps us out in various ways to identify what's going on and what's included and what's excluded with these parentheses. And so when I traverse across the parenthesis, the corresponding parenthesis for that group will momentarily be highlighted bold. And so I'll jump back and forth across this parenthesis next to the 3, and you'll see that its partner parenthesis in front of the 2 will highlight bold. So that's pretty handy. So now in our order of operations, Excel is going to look for parentheses. It comes down to the formula. It sees it. And so it will do 2 plus 3, and it will reserve a 5 here. And then it will look for exponents. It sees none. Go to multiplication. There it is, times 4. So it will take the previously calculated 5 times 4, and pressing enter, there we get our 20. Now, if we wanted to have, say, more operators in this formula, and let's say we'll just do times 12. Now, due to the order of operations, with no additional parentheses, this is going to calculate, it's going to continue to calculate left to right after the parentheses, just because that's how the order of operation works. But for demonstration purposes, I'm just going to show you that we can nest an additional set of parentheses to ensure that this happens before we multiply times 12. And so here's another useful thing that Excel does for us is that when we start to have more than one set of parentheses, it starts to color code the parentheses so we can quickly identify what is included and what is excluded from this group of parentheses. And again, no matter how many sets of parentheses we have, as we traverse across a set of parentheses, uh, it momentarily bolds them. So I'll press enter. You see the answer we get is 240, which is 20 times 12. So, okay, that I think is enough for just a basic introduction into how formulas are executed in Excel. Now, formulas can become extremely complex, and many different levels and layers into how you nest different operators together, and we're certainly going to get into that. That's not for today's video. Today is just the basics still. So now that we know that, let's go ahead and slide over to where I've got some headers pre-written. And so let's see some of these formulas in actual practice, how we might actually use them in everyday life. So here we've got this random sampling of something we might see in an employee spreadsheet, and let's go ahead and enter some data here. So we'll start with employee ID. We'll make it 001. And then for name, we'll say John Doe. And for hire date, let's say it's today. Let's say it's Christmas 2025. Base pay, let's make it $28.50 an hour. And for overhead, if you're not familiar with overhead, so overhead is what's calculated into an employee's overall pay. So while John Doe might take home $28.50 an hour, there's much more to John Doe's pay than just what John takes home. There may be health insurance or dental coverage or life insurance, unemployment insurance, all these things that the company pays for this employee that aren't expressed in that particular employee's take-home pay. So we'll say that this company's overhead rate for the employee comes to $22.61 an hour. Okay. So for a monthly salary, we can say now our calculation or our formula will be equals, and we want to reference the base pay and the overhead. And so to reference that, we're simply going to, once we've pressed the equals symbol, we're going to take our cursor and we'll click on that cell. And so you can see here, John Doe's monthly salary equals cell E4, which is his base pay. And we'll say plus overhead pay times, and we could say 8 hours a day times 5 days a week times 4 weeks in a year. We press enter, and we get a number of just over $3,500 a month. Except this is not the right number, and the issue that we find here is the same thing that was in our demonstration. We need to group this base pay and overhead pay before we start multiplying times days and weeks and all that jazz. So the solution is the same. We're going to group this into a set of parentheses so that this addition happens before all the multiplication. So having grouped that inside parentheses, we'll press enter, and we see that John's actual monthly salary is $8,100 a month. Okay. Now, double clicking to go back into edit mode of my cell. This is a very rough form of calculating monthly salary. And the reason being is because uh, while a normal workday is 8 hours and a normal work week is 5 days a week, 4 weeks in a month is not very accurate. In fact, there is very seldom 4 weeks in a month. That's simply an average. And so, if we're going to average, uh, we want to average to the with the most fidelity as possible. And so, instead of multiplying all these hours a day and days and weeks in a month, instead, I'm gonna get rid of that. I'm gonna say that on average, an employee works 160 hours in a month. And that's simply 40 hours a week times 4 weeks a year. We get 160 hours in a month. And that's my preferred method for calculating monthly salary. So I'll press enter, and you can see in this particular example, we get to the same result. Um, but it's based on hours rather than trying to multiply days times weeks times hours. Now, when we get to annual salary, we could say equals, and we can reference the monthly salary times 12 months in a year. That makes sense. And you see, we get 98,000 and change for John Doe's monthly salary. But again, trying to get the most fidelity as possible, instead of 12 months a year, we want to do the average number of hours worked for a full time employee in a year. And that number is 2080. So for a person that's working full time in a year, they will have worked 2,080 hours. We press enter. Whoa. We we press enter because we were still multiplying times monthly salary. John got a huge pay bump. So let's go ahead and fix that. Instead of monthly salary, let's remove that portion. And we're gonna start by opening. In fact, let's get rid of all this. We're gonna start by opening the parenthesis, and we're gonna say base pay plus overhead pay and close our parenthesis, and then we're going to multiply by 2080. There, that's more like it. So $106,308.80 in a year. And you can see that the previous number that we had there was just shy of $100,000 a year. And so it's a pretty significant difference when you talk about multiplying times 2,080 hours in a year versus using a broad brush stroke of multiplying just a monthly salary times 12. So we'll go ahead and we'll enter some more information down here for a couple more employees. Uh, and so, to leverage the work that we've done with these formulas so that we don't have to continue to rewrite these formulas, what we're going to do is we're going to autofill some of the cells below it. So I'm going to highlight by clicking monthly salary. I'm going to click and drag across to annual salary. You can see that these two cells are highlighted. And you see in the bottom right hand corner, there's that little green block. And you'll see that my cursor currently is a white cross. And if I hover over that little green block, my white cross will turn to a black cross. And that's how we know we've activated the fill handle. So this little black cross is the fill handle. And what that allows us to do is to click and drag, and this will fill all the cells down below. And if we went too far, we can simply click that fill handle again. We can drag back. And you can see that our formulas, by looking up in the formula bar, our formulas are all there. And because there's nothing in these referenced cells, uh, our formula ends up being 0, which that's fine. That's how we want it. So let's go ahead and put another employee in here. We'll do a Jane Doe, and we'll make the hire date January 16th, 2015, and base pay is maybe 3105. Overhead, again, because this is a company-wide or division-wide calculated number, we know that all these people will receive the same overhead rate. And there you see we get our calculations to perform automatically. And for a third person, we'll say Tom Jones. Oh no, what am I doing, guys? Tom Jones, and the hire date is, we'll make it April 1st, 2022, with a $30.50 base pay. Again, the 2261. And there you see our formulas are working as expected. And so a portion of our data set or table that was formerly longhand or calculated individually, it now auto calculates. And that's how we start to go from basic Excel user into a more intermediate user, by integrating some of these automated functions. Now, we've put in work here and we want to protect our work. And so one of the ways that we do that, we don't want to, let's say we're sharing this data set or this worksheet or this workbook, and we don't want all of the work that we've put into our formula to be compromised either intentionally or unintentionally. And so one of the things that we're going to do is say, hey, this whole section over here, I want people to be able to edit and input information over here. And so I'm going to highlight that whole section, and I'm going to right click anywhere. And I'm going to go down to Format Cells. And here in Protection, you're going to see the right tab, Protection, you're going to see Locked has a little checkbox next to it, and I can check or uncheck that. And I want to make sure that it's unchecked so that people can enter information there. I'll press OK. And then for this section, I'll right click and I'll Format Cells. And I can see that this section is checked. And in earlier versions of Excel, the default was, kind of either locked or unlocked, but in newer versions of Excel, it starts to identify where formulas are, and it will default lock formula sections. But just to ensure that that is in fact the case, we always want to make sure, where we've got formulas, we make sure that those cells are locked. We're going to press OK. And then in order to lock down this sheet, we're going to go up here to our ribbon and we're going to go over to the Review tab. And on the right side of the Review tab, you've got this Protect section. And you can protect sheet, you can protect workbook, you can allow edit ranges, all that sort of stuff. But for just very basic protection, we're going to say Protect Sheet. And when we select Protect Sheet, you can see it wants to know, do you want to provide a password to unprotect the sheet? Now, I typically don't, depending on who the workbook is for. If it has sensitive information, and it's being used across a wide range of users, I will password protect. But the only thing I'm trying to accomplish in protecting my sheets is so that if you want to get in there under the hood and start messing around with formulas, I want you to need to make a deliberate action in order to do that. So I will protect my sheet with no password. Again, depending on what the data set is and who the users are. But there's also a sense of personal responsibility where if you made the effort to unprotect the sheet and then you went in there and you broke formulas, um, that's that's a responsibility that I think you need to own as a user. So I will protect the sheet. I will lock cells down. Uh, but if you absolutely must get in there and mess with formulas, by all means, you do you. But you're going to have to intentionally perform that function. So, in a way, I feel like that onus is then transferred to the user. It's just my personal philosophy. You can, of course, always password protect, and then they'll need to come to you to get the password, and that gives you an opportunity to have a just a brief conversation about why it is that they need to unlock the worksheet. So there's all these options here where you can select what they can do when the sheet or the workbook is locked. You know, can they select lock cells? Can they select unlock cells? Any of these things. Um, and so a check mark, of course, is yes. No check mark is no. These are all the things that I like to do, and I personally prefer that they're not allowed to select lock cells. So if a cell is locked, you can't touch it. You can't do anything. It's just not available for anything. You can't even select it. So that's how I like to do it. I'm gonna press OK. And so now that this is protected, you can see that I can click and drag to select, and I can't even select over my locked cells. I can't edit them, I can't select them, I can't do anything. But all of this area where I said it was okay, I can enter random bits of information, and that's fine. And if for whatever reason, let's say I was back in this workbook and I needed to get in here, I just simply unprotect the sheet, and now I can get into each of the cells and do whatever it is I need to do. So yeah, I think that's good for today. I think that that is a good intro into the basic mathematical function of Excel. Um, Math is definitely Excel's strong suit. All these formulas, and so we're going to spend a lot of time working through formulas and um, how to leverage certain formulas and nesting them together. But for today, I think that's plenty. So, as always, if you benefited from this video, or if you know somebody that could benefit from this video or this series, by all means, forward my channel or this video onto them. And I sure would appreciate it. We'll see you next time in video 5, where we go in depth onto a topic we just barely touched on, which is autofill. I hope to see you there. Thanks, everybody.